Hi there. On the workbench today we have a B&K Precision Model 2050 RF signal generator that belongs to a friend of mine. This unit is a solid-state RF signal generator covering 100 kilocycles to 30 megacycles in 6 separate bands. It also features internally generated 400 Hz modulation, and that's the particular problem with this unit. My friend reports that it intermittently but fairly consistently loses the internal modulation. I've looked at this unit on one occasion previously and errantly diagnosed it as having a problem with the three-way slide switch that controls the modulation source. After hitting the switch with deoxit and cycling it, modulation returned, and it seemed to work just fine, so I gave it back to my friend. Well, on a recent visit to that friend's house, we were playing around with one of his oscilloscopes, and I happened to notice that once again, the unit would not generate internal modulation. I brought it back home with me, and when put on the bench, was working just fine again. Internal modulation was present and looked normal. I removed the top cover and visually inspected the insides of the unit very carefully, but found no physical issues such as burned components, bad solder joints, loose connections or wires. The build quality on this unit is very good for a simple piece of test equipment, and I couldn't even find a solder joint that even began to look questionable. It was really assembled quite nicely. I then used a fiberglass alignment tool to probe around the various components on the circuit board and check for loose connections while the unit was powered on and connected to an oscilloscope, and found no trouble. I then began to wonder about heat. My friend leaves this unit running when his workbench is powered on, so it runs for quite some time before he actually goes to use it. First, I tried freeze spray and focused on the unit's 7 silicon transistors, as they're the most likely culprits for such a failure. The freeze spray produced no results. A nice, modulated RF signal remained on the scope while spraying all 7 of the transistors. I next switched over to a heat gun, wondering if heat could be causing the issue, and sure enough, as soon as I heated in the area of Q5 and Q6, which are 2SC458 NPN transistors, which comprise the AF oscillator and buffer amp, which actually generate the modulation signal abruptly disappeared and would not return, even after I let the unit cool down for about an hour. Probing with the oscilloscope on Q5 and Q6 revealed that the AF oscillator which supplies modulation, which is Q5, was not running. It was then I decided to replace both Q5 and Q6. A little reading online revealed that the 2SC458 is a notoriously squirrely transistor, known for having odd failures like this. Judging that the functions of Q5 and Q6 in this unit didn't call for a transistor with specialized specifications, I replaced the 2 suspected bad transistors with generic NOS NPNs I had on hand. I did make an attempt to match the beta value of the new transistors as closely as possible to the old ones. This was in the neighborhood of 175. I unsoldered and removed Q5 and Q6 and replaced them with the generic transistors and retested the unit. Sure enough, the problem was resolved and didn't return, even with the application of direct heat as was done previously. I also gave the unit a 24-hour period of constant running with the internal modulation enabled, and after checking it again, it was just fine. In fact, after replacing the transistors, the percentage of modulation looked to have increased a little bit. The specification on this unit calls for 40% modulation, and I would say that it was closer to 50% after replacing the transistors. I thought it would be fun to see if I could do a double-blind test with the failed transistors that I pulled from the unit. I heated the failed transistors and checked them in my GM328 Chinese component tester from eBay. These things really don't test the transistor in the strictest sense of the word. They only show beta, the base junction voltage drop, and a couple of collector to emitter currents. But still, I wanted to see if I could get a failure of some kind to register. I heated the failed transistors and did before and after checks, but didn't see a pronounced failure indicated on the tester. I even tried bringing the soldering pencil close to one of the transistors and trying again with much more concentrated heat. It was interesting to notice how the transistor's beta started off at 175 and increased each time the transistor was subjected to heat. Still, I was unable to reproduce a failure. I checked the unit's calibration while I had it open and found it to be within a few hundred hertz. Pretty good for a unit with a mechanical dial which is subject to parallax and other induced errors. This isn't a precision instrument, but it is good enough for aligning radios and for other light-duty applications. I reassembled the unit and returned it to my friend. Thanks for watching. Hopefully this video is of some use. See you next time.